Okay, we're going to look at polynomial functions and what we can use to help graph them, such as things like the order. So what is an order? It's something that like a root has that you can classify it by. So for example, if this g of x, we know that x plus 4 is the root, or in factored form, or the root would be -4, and all of it's to the exponent of 1. So that would be order 1. So this the exponent is going to be the order. And then we've got x plus 2 all to the power of 2. So we know that the root will be -2. And then the exponent is 2. So it will be order 2. And then we've got g of x is equal to x minus 3, and all of that's in brackets, the exponent of 3. So we know that if it's to the exponent of 3, the root will be, x minus 3 means the root's going to be x equals 3, and the order is just going to be order 3. And all of these orders, they have different kind of like characteristics and like how you can tell the difference between them. So let's just graph like an approximation. We know that y equals x, or f of x equals x. That's just going to be like a linear function, and we know exactly what that looks like. That's like grade 9 stuff. So let me just plot the root. It's going to be x plus 4, so x equals -4, so that's 1, 2, 3. So that's the root of g of x, and we know that it's a linear function, so it will look something like that, but obviously a bit more straight. So we got order 2 now. So we know that something to the exponent of 2, let's say like y equals x to the power of 2. That's just quadratic, it's a parabola. So we know if this root is if x plus 2, it means that it's to the left 2. So x is -2. So it's going to look something like that. Just like a general parabola. And then g of x, let's look at that, x minus 3, so plus 3, x equals plus 3 is the root. And that's all to the exponent of 3. So we know that let's say y equals x to the power of 3 is a cubic function. So if we take a cubic function and slide it 3 to the right, then it'll look something like that, right? There, something like that. So as you can see, all of these orders, they do different things because the shape of the function looks completely different for all of these. So we can see order 1, it's if this was the x-axis right here, you can see that it passes straight through the x-axis, almost as if it just kind of like ignores it almost. So we can tell that the order 1, a linear function, in this example, order 1 means that the root will pass through. And then order 2, we know that it looks kind of like a parabola, so it's going to kind of go like that. So it looks almost as if it's going to like go parallel to the x-axis, and then that's when it touches, and then it doesn't cross it, it actually just bounces right off of it. So we can say that this one bounces back. And then the last one, order 3, this is kind of the hardest one to, I guess, classify the behavior of it. It looks like it's going to pass through, but then right at the last second, it looks like it's going to go parallel to it, but then it kind of slices through it on a diagonal, and then it shoots back up. So that's what that one looks like. So it almost looks like it slices through it because it doesn't pass through it. It slides almost through it, like it slides through with it almost. So we can say this one kind of slides through it. So let's say that we have a polynomial that's to degree 4. So that means that there's 4 there's up to 4 roots. So that means that there could be one root that's order 3 and one that's order 1, or there could be 4 roots that are order 1, or maybe just 2 that are order 2. But we know that with our n behavior, which quadrants it starts in, and we can combine that with our knowledge of the different orders, and we can get like a really good, accurate general idea of what the function could look like. So let's look at an example. So we've got f of x is equal to negative 4x cubed minus 12x squared minus 9x. So how can we even begin to start graphing this? Well, we can point out a couple things straight from the beginning. We can see that it's got a negative leading coefficient, and that it's to degree 3, because that's the highest degree. So we know that something that's to the degree 3, and it's a negative leading coefficient, will start in quadrant 2, and it will end in quadrant 4. So we know that's the end behavior. But what else can we tell from it? Well, the answer is nothing. We can't really tell anything from this because it's in standard form. So what could we do to this to maybe get more information and possibly find the roots? Well, we could factor it. So to factor this, the first thing that I could see for this one is that you can take out a negative x from all of these. So we can do f of x, so then negative x, and then this would be 4x squared, this would be plus 12x, and this would be plus 9. So now we can take that trinomial and factor that. So what are two things that will add to, hold on, let me change the color. There we go. Something that's going to add to positive 12, and something that's going to multiply to 36, because 4 times 9. And that's going to be 6 and 6. Positive 6 and positive 6 will work for that. So we're going to carry this out. 4x squared, and then plus 6x, plus 6x, plus 9. Put that all in brackets. So now we'll continue with this. What can we factor out from 4x squared and 6x? We can do a 2x from there. So we'll do 2x, and then in brackets, 2x plus 3, and then we can factor out a plus 3 from these guys, and then do 2x plus 3 again. So then we got f of x will be equal to negative x, and then we can group these, 2x plus 3, and then we've got another 2x plus 3. So it looks like we're finished, and we have two roots that are the same that are at order 1. And then we've got another root that is equal to 0, and that's also order 1. But there's something else that we can do to this to simplify it even further. So I'll start off giving a hint. Let's say that we know 5 times 5, that's equal to 25. So what's another way that you could write 5 times 5? You do that as 5 squared. That's equal to 25. We could also do x times x. That's going to be equal to x squared. So if we can also combine these and just rewrite that as x to the power of 2. That will also equal x to the power of 2, obviously. So if we want to, and you kind of have to, you have to write this as negative x, and then 2x plus 3 times 2x plus 3 is just going to be 2x plus 3, and that's all squared. So now we have two roots. We've got this one right here, number 1, and then we've got, oh whoops, there we go, and then we've got this one. This is our second root. Okay, well, let's start with the first root. This one's pretty obvious. It's just gonna be x is equal to 0 because it's just x. Negative x equals 0. If you divide a negative by both sides, it's literally just gonna be x is 0. So one of our roots is gonna be there. So let me graph that right there. Oh, wrong color. There we go. It's gonna pass through the origin, and then our second root is going to be 2x plus 3, and then we're going to equal that to 0. So we're going to subtract 3 from both sides, negative 3, and then divide by 2 on both sides. So negative 3 over 2 is going to be that one. So then that root's going to be right there. So yeah, you know what? I'm going to change the color of that other root. There we go. So those are where our roots are going to be. And what did we learn from the orders and like what the orders do? We learned that something that's ordered 1, which is this one, which is the first root, because it's to the exponent of 1. It's just x to the power of 1. That means that it'll pass through. So the one that passes through the origin, the green one, that's going to pass through. And then the one that's 2x plus 3, that's all to the power of 2, which means that that root is order 2, meaning that that's going to bounce back. So we know that the first one in pink is going to bounce back, and then the next one's going to pass through. And it starts in quadrant 2 and it ends in quadrant 4. So doing that, we can just graph it approximately, and we can say that the first one's going to bounce back like that, and the second one, it's got to pass through like that. And that will continue, and that will continue. So that is how you could graph approximately something like this.